Hello everyone, so I am Ryan Cilianto and welcome to my video presentation. So today I'll explain one of the most practical and beginner-friendly algorithm in machine learning, which is naive-based classifiers. So this algorithm is especially powerful for classification tasks like detecting spam emails or understanding the sentiment of a tweet. So let's proceed. So what is naive Bayes? So naive Bayes is a probabilistic algorithm based on Bayes theorem. Okay, so it helps us predict the category of data like whether a message is spam or not spam. The term naive means that the model assumes all features like words in a sentence are independent from each other. So this assumption isn't always realistic, but it makes the model very simple and efficient. Okay, so this is the formula of Bayes theorem. Okay, so formulas, these are the formulas. So let's proceed. So this is the training data sets. So let's now walk through the full example. Okay, so we'll see use example data set of the text messages. So this task is to classify them as spam or not spam using naive Bayes. So this is the training data set, I mean. Okay, so now we have 4 messages. 2 are spam and 2 are not spam. So the goal is to train a classifier to recognize which type a new message belongs to. Okay, so let's proceed. Okay, so first is collect the word frequency in its category. So we'll tokenize the word, so break into the individual terms. So let's proceed. So the spam messages are buy, cheap, now, and limited. So the next time offer, that is the okay, so let's repeat. The spam messages are buy, cheap, now, limited, time, and offer. So the spam messages are let's meet at 6 p.m. lunch tomorrow sounds good. Okay, so this is the step-by-step word frequencies. Okay, so as you can see, the spam count are, so the spam is you can see the spam count is number 1 and the not spam is 0. Okay, so the spam count is number 1. Okay, so as you can see, the buy, the cheap, now, limited, time, offer. Okay, so let's meet at 6 p.m. lunch tomorrow sounds good are not spam. Okay, as you can see, this is like check or wrong. So the check is number 1 and the 0 is the wrong. Okay, as you can see, the one is in line to the spam count, and the one in the spam and the one in the second column or row, I don't know. Okay, so that is not spam count. So start in let's meet up to the last. Okay, so let's proceed. Okay, so here are the prior probabilities. Okay, so this is the prior probability. So we calculate the prior probability. So the probability that a random message that is spam or not spam. So okay, so P quantity spam is equal to 2 divided by 4 is 0.5, and second one is P quantity of not spam is equals to 2. This is the formula, actually this is the formula, and that is a given number, which is 2, 2, and 4, 4. So the result of these two is 0.5. Okay, let's proceed. So let's classify a new message. So this is a buy now offer. So we'll use naive Bayes to determine whether it's more likely spam or not spam. Okay, this is the example. So now listen. Okay, so now as you can see, if a word doesn't appear in a class, excuse me, it's probably becomes 0, which ruins the whole multiplication. So to fix this, we will use Laplace smoothing. Okay, so P word plus count is equals to count plus 1 over total word plus number of unique words. Okay, so for spam, as you can see, there are 6 words in the spam. Okay, in the total words, and unique words are 15. Okay, so denominator is equals to 6 plus 15 is equals to 21. If you plus the 6 and the 15, it will become the 21. So for not spam, the total words are 19. So total words 9 plus 15, which is the unique words, is equals to 24. Okay, so this is the word probability table. Okay, so as you can see, the buy word count is spam is number 1, offer now 1 in spam. Okay, so there are all spam. As you can see, count in not spam is 0. Okay, so this formula and buy, they are all the same. If we calculate this, the result all is the approximately 0.095 in the word spam. In the word not spam, the result is approximately to 0.042. Okay, so the final probability calculation is, if we calculate this, okay, so let's read the formula. So P spam is equals to P quantity of buyer spam. Buyer spam is times P quantity of now or spam on our spam times P quantity of offer spam. Okay, that's the formula. And the okay, so let's break down the given number. So 0.5 times 2 over 21 times 2 over 21 times 2 over 21. So first is to times the same. Yes. Okay, so bring down the 0.5 times, this is the result, which is 8 over 9,261. So if we first is to divide it, because this is the parenthesis belong to this parenthesis. So first is we divide first. Okay, so if the result is done, so you times to 0.5 and the result is approximately to 0.00432. And for the not spam messages are, okay, so bring down, so 0.5 times 1.24 times 1.24 times 1.24. So the result, so bring down 0.5 times 1 over quantity of 1 over 13,824. So if we calculate them, so the result is the approximately 0.000036. 0.000036. Okay, so since excuse me, since 0.000432 is greater than to 0.000036, the message is classified as spam. So this is the Python code. So as you can see, the counter excuse me, as you can see, the counter vectorizer, this is to convert the text into word count vector. So for example, buy chip now becomes buy is equal to 1, chip comes to 1, and now becomes to 1. Okay, so yeah, para magets. So as you can see in the fit transform, text creates a word matrix for our training data. Okay, so in the, as you can see in the multinomial NB creates our naive Bayes classifier, and fit trains the model of fit trains the model using the new message into the same format. Okay, so the last is the prediction. Okay, so the predict gives us the output of the class, either spam or not spam. Okay, so gets. Thank you for listening, guys. So this is the takeaway. So naive Bayes is fast and simple. So it is assume independence between features. Works best for text classification problems, and it's used in spam filters, sentiment analysis, and document categorization. Okay, so guys, thank you for watching for this video. I hope this presentation and example help you clearly understand and how the naive Bayes classifier works. So from theory to calculation to code. Okay, so okay guys, so thank you for watching. Bye bye.